Now the wife bought me a inexpensive AC/DC amp meter, and along with it, it'll do voltage checks, resistance, and check diode. So I just want to see how accurate it really is. And on the batteries right now, with the furnace cranked up, we're showing 13.6 volts DC output from the converter. So that sounds about right, and we'll compare it to my fluke meter. And so for comparison, I've got my fluke meter that I've had for quite a long time. We're showing 13.58 volts, and on the new meter we're showing 13.61 volts, so it's very close. Looks like from an accuracy standpoint, not too shabby for a multi-purpose meter. And of course, what's nice about this meter is it's got the clamp, inductive clamp, so that we can check AC and DC amperage readings and do it safely. And yeah, the wife thought I might need it for something to play with. And so I was curious, I wanted to see how many amps the furnace motor would actually draw when it's running. And so right now we're drawing 9.3 amps with the furnace running, and we're on battery power only. We have shore power disconnected, so it kind of gives you an idea how many amps your furnace will draw. You've probably seen in writing and stuff what they draw, but here you can actually see how much it's drawn, and we're simply clamped around the positive lead off the battery, heading up to the bus inside the fifth wheel. But 9 amps, and so now we'll go turn the furnace off and see what sort of a draw is on the 12 volt DC system. Okay, we've switched the new little meter back over to amperage DC, and with absolutely nothing running, there's no lights turned on, the fridge is turned off, so absolutely nothing, you can see that we are in fact drawing 0.3 of an amp. And we'll turn the battery cutoff switch off, which we just did, and you can still see that even with the battery cutoff switch, let me get this focus, you can see that we have a little bit of residual draw across that battery, not very much, and that's parasitic draw for things that are still directly connected to the battery, and that would be things like the level up control panel, the LP detector. Those are always have power to them regardless of where we put this switch at. So we'll turn the battery switch back on, and you can see with the battery switch back in the on position, we're drawing half an amp. Did show almost 3/4 of an amp, but that's with absolutely nothing turned on in this fifth wheel. So that kind of gives you an idea of parasitic draws that your batteries are going to get. We're going to again look at the DC reading off of this, get the right reflection there. 12.6 volts off the 2 batteries that are 7 years old. So now we're going to go plug the shore power in. We're just using a 15 amp outlet here at the house. Have done that for over 25 years with the various RVs that we've owned, but we'll plug shore power in and we'll see what kind of voltage output we get from the converter since we let the batteries run the furnace just a little bit. And I expect to see a rise on this voltage from 12.6 to probably 13.4 to 13.6 volts DC to indicate that the converter is actually working properly. So we'll do that next and see what happens. Okay, so we've gone and plugged in the converter, or shore power I should say, here at the house. It's just a 15 amp outlet. And so you can see that the voltage rose from 12.6, which was off the batteries, to we're showing 13.5, which means the converter is now running and it's charging these batteries up, plus supplying any other DC loads that are on the system right now, but 13.5 with the converter running. And we've switched the meter over so that we can monitor what sort of amperage is actually coming into these batteries from the converter. And you can see 6.5 amps you're currently charging these two batteries, and it's dropping down a little bit now, which I would expect it to. I ran the furnace probably for about 5 minutes of run time plus its purge time, so you can see that charge that's coming off the converter is slowly decreasing. And so that's how you can very easily tell if your converter is working or not. And a little meter like this, it's very inexpensive. The wife paid 59 bucks for this. It also has inputs on the bottom. You can see the leads there, and we can measure voltage, we can measure resistance, and a couple other things. This little meter even measures temperature off of something, so I haven't tried that yet, but a very handy little meter, all in one for the RVer, and something you might want to look at. We'll take another peek here. It's been about a minute. You can see that amperage that's coming out of the converter to these batteries has gone from what was almost 7 volts, or dropped down to, 7 amps. We've dropped down to 3.9 amps now, so you can see that the batteries are getting a charge pretty quickly, which tells me that these batteries, I was thinking about replacing them. They're 7 years old, but seeing what I'm seeing, the fact that I didn't add any water to these batteries from October when we winterized the fifth wheel, and it's now the 18th of February, and the electrolyte level on both batteries is still just about where it was, tells me that I would be wasting a couple $100 to go buy batteries right now. So we'll forego that expense and keep the money in our pocket. But again, a handy little feature. And yes, I know some of you are going to tell me, well, I've got a fancy panel inside that does all that too. Well, that's nice, but I can get this meter in places that you can't get that nice fancy panel meter that monitors the voltage and stuff. That's why I recommend the RVer have a handheld meter that measures volts and ohms, and amperage is a nice touch. And for the cost of this meter, you really can't beat the price, and it's very accurate when I compared it to my fluke meter, as you saw earlier in this short video. I am actually quite impressed with the condition of my batteries. They're taking a charge very quickly, which means they were fully charged at 7 years old, and you know, we're down to 2.5 amps now. And we'll switch over to voltage, and we'll take a look, see what kind of output we're getting from the converter. 13.6 volts out of the converter, which is normal. You should see somewhere between 13.4 to 13.8 when there's been a draw, or if there's a draw on the converter. And if it has set for more than about 24 hours or 30 hours, I can't remember WIFCO's spec exactly, that voltage output will drop down to 13.2, which is more or less a maintained voltage, so that it doesn't, it will maintain the batteries, but you won't overcharge the batteries. So, and we'll take one more peek and see where we're at with the current right now. That's the amperage that's coming into the batteries. So we're down to 2 amps, and we've been less than 5 minutes out here. So complete waste of money to go buy new batteries, even though they're 7 years old. You know, I just want to talk a minute about these meters. You're looking at a fluke meter that probably cost, I don't know, $400 or $500. Yeah, they're nice and they'll last forever. But for the RVer, you know, you just don't need to spend that kind of money unless you just got money to burn. A little meter like this one, and we'll you can see the name on this one. Wife got it off of Amazon, and I think she said she paid 49 or 59 bucks for it. And it will do just about everything that this meter will do. And from what I can tell, the accuracy on it is very good. Comes with a little case. It comes with a set of probes. Let's get this out of the way. It comes with a set of probes The tips on the probes are a little short for my taste. You can get that in focus there. You can see the length of the probes, but they're adequate, except if you wanted to stick this into an electrical wall outlet, it's probably not going to fit. So you wouldn't be able to measure your AC voltage at a wall outlet compared to, you can see the length of the tip on this other set of leads that I have. So that's something to consider when you're buying a meter. But you know, you can buy these leads just about anywhere, Harbor Freight, places like that, and get one with a longer tip on it so that you've got a little bit more test length there. And I actually misspoke. Upon further examination, these test leads have a cover on them that'll twist off like so, and we actually end up with a nice long test lead just like you see on my other set of leads that I use with a fluke. And so these do screw off to give you a longer reach. They've got this shorter isolation cover on here if you're reaching in somewhere so that you don't accidentally short something, but the covers do come off, and so in fact you could stick these into a wall outlet, and we'll do that here in just a minute. And if you notice on the bottom of this meter, there's two places to plug in. One says common, and that's where your black lead goes. The other says input, that's where your red lead goes. And so we've got the meter leads that came with the meter plugged in on the bottom, and we've got the little protective tips removed. So now what we're going to do is go measure a 120 outlet here in the fifth wheel and see how easy and how accurate that it is. Okay, we've taken this new little meter and we've set it to the volts scale, and you can see where it says V. The pointer is pointed to V, and this one is combined AC or DC voltage. And you can see that we're in the bottom outlet on the wall here, and we're reading 122.2 volts. And we have my fluke meter right next to it, and we're reading 122.114, and we're plugged into the top on the same outlet. And so from an accuracy standpoint, the little meter on the right is just about as good as this fluke meter. So, you know, it's something that, quite frankly, if you're going to RV, you need to carry a multimeter, and you need to learn how to use one. There's a lot of YouTube videos out there, and you can learn very easily how to use a meter, how to test AC voltage, how to test DC voltage, how to test resistance. And if you bought a meter like this one, measuring current, if you're curious how much amperage your batteries are drawing, etc., it's a very handy meter to have. It'll keep you from having to call some mobile tech out or take your rig to some place to get it looked at for a simple electrical problem that you might be able to fix yourself. Okay, we've wiped all of the leveler legs and landing gear legs down, and we still have the shore power connected. Converter's putting out 13.7 volts. What I want to do now is disconnect the shore power, and we'll operate just off battery power. And we'll pull the slides in and take a look at where the voltage is at on the batteries. Okay, after pulling in the 3 hydraulic slides, this Alpine, all slides are hydraulic. You can see we're at 12.4 volts. So now we're going to raise all the leveler legs up, and we'll check the voltage again. And when we look on the meter that's over on the battery, we're showing about 12.3. And so that tells me that maybe I might need to take this ground off back here that you see. Those 2 white wires are going to frame. We might need to clean those off a little bit and maybe take the terminal connections off and clean them. They haven't been cleaned since October. They look nice and clean, but I can't see the bottom side of them. And so we might do that here in a little bit. Okay, so we're running the auto level right now, and you'll see here in a minute, 60 amps is how much we're drawing when that hydraulic pump motor runs. You'll see it again here in a minute. The left side levelers are going down. That's 45 amps of current off the batteries. And as soon as those get down, the right side levelers, and that's the mid-rear, will start coming down. Okay, now the right side or passenger side mid-rear levels will come down. And we're drawing 38, 39 amps. There's 45 as it actually starts to lift a little bit of the weight. And you saw it almost hit 60 as it actually got a little bit more weight. And that'll do a final front to back correction. And you can see almost 60 amps of current draw off these batteries. Okay, and we got a successful auto level. I wanted to cycle the landing legs anyways since they've been sitting here all that long. So that's why we wiped them down. And we'll take a quick look-see, make sure that we don't have any hydraulic leaks, which I don't think we're going to have. And you can see that shore power is disconnected still. And we don't have any hydraulic leaks anywhere, which is a good thing. So now what we're going to do is extend all the slide outs out, and then after I get done, we'll go plug in shore power and see how many amps that converter is actually put into the batteries. Okay, we just fully extended the slides, and we want to look and see where our battery's sitting at, 12.3 after cycling the landing gear, doing an auto level, and pulling all the slides in one time and extending them. So 12.3 volts is where we're at for our DC power coming off the batteries. And now we're going to go plug in the converter, and we should see that output jump up probably about 13.8 after all that hydraulic pump motor running. Okay, we've set the meter to read amperage, and as you can see, we're drawing about 14.5 amps out of the converter and recharging these batteries. So that's about normal after a cycle like that. So that's good to see, and we'll take a look and see what the voltage is on the batteries, 13.3. So we're getting a good charge coming off the converter, and the 13.3 is indicating that the converter is working like it should. We'll switch back over to amperage one more time. We're down to 12.7, so the batteries will charge back up fairly quickly, but it gives you an idea what you can do with an inexpensive meter and just a little bit of time of learning how to use it. And some would say, well, why do I need a meter to check that? And I don't really need it. Well, yeah, you do. I'm going to show you how you can use a multimeter. We'll use it in the ohms scale, and we can measure resistance. And in this case, we're going to check an ATC fuse. And your power center has a plethora of 10 and 15 amp ATC fuses in there. So if one blows, maybe the red light will light up if there's a load on the circuit, and maybe the light won't light up. And you can sit there and guess and play the guessing game and switch fuses all day. Or you can drag your meter out, and in 5 seconds you'll know if the fuse is good or not. First thing I want to do is verify if the leads and everything are showing me a good resistance, and we're showing just about 0 ohms. Anything less than 1 ohm of resistance across a set of meter leads is okay. And so we know the leads are good, so we know the meter will measure resistance good. Now we're going to take this ATC fuse. Yes, you can clearly see that it's not blown, because you can see the conductor in the center there is not burnt in half. But we'll show you how to use a meter real quick and test that fuse. Okay, so I've put 2 clip leads from the meter across this ATC fuse. And we'll take a look at the meter, and in fact, it shows 0 ohms of resistance, so that tells us that fuse is good. If the fuse wasn't any good, then when I disconnect the lead, here we're going to see OL, which means open line. So if you see that, that's telling you that the fuse is burnt out. Or if you're trying to measure a circuit, same thing, that you've got a break in the circuit somewhere. So it's very easy to use one of these meters if you spend a few minutes and learn how to use it.